Today I'm going to demonstrate how to make plots in Julia. The package we're going to use today is plots, and the first plot we're going to make is a scatter plot. In this case, we will plot x from 1 to 10, and y are 10 random numbers. The first thing we're going to do is to assign a vector from 1 to 10 to x, and assign a vector consists of 10 random numbers to y. Now you can see that we have our x vector and y vector in our workspace. We can make our scatter plot by scatter function. This is our scatter plot, and as you can see, the plot will be displayed in your default browser. Now we're going to make a line plot. We can do this by the plot function. We can also add a line to our plot by using plot exclamation. First, let's define a random vector z, which are 10 random numbers. Then we add a z line to our plot by using plot exclamation. Now we have a plot with 2 lines. We can also plot multiple lines by plotting matrix with multiple columns. So each column is a separate line. In this case, we define y as a 10 by 2 matrix. And then we use the plot function. You can see that we have a plot of 2 different lines. Now we might want to modify our plot. We need a title for our plot. We need a label for our 2 different axes, and we need a label for our 2 different lines. So again, let's start with the plot function, plot x and y, and let title equal to my plot. The label for our 2 different lines. Let's make the first line y1, and the second line y2. We can define the line width with LW command equal to 3. Now we can still add the labels for our x-axis and y-axis. We will add our label to the x-axis and y-axis by using x label exclamation and y label exclamation command. X label exclamation. Let's add x-axis. And we will add a label for our y-axis. Now I'd like to demonstrate how to plot different distributions in Julia. To plot distributions, we need two packages. The first package is distributions, and the second package is stat plots. Under the distributions package, we can define different distributions. For example, we define D is a normal distribution with mean equal to 3 and standard deviation equal to 5. Now we can plot the normal distribution with mean equal to 3 and standard deviation equal to 5 under the statplots package with command plot D. Let's give it a title equal to normal distribution. There's a label equal to normal curve. And we can define the line width equal to 2 this time. We can also plot other distributions, for example, like gamma. Let's plot a gamma with shape equal to 1 and scale equal to 5. Title equal to gamma distribution. Label equal to gamma curves, and line width equal to 3 this time. The next part I'm going to show is how to make subplots. To make subplots, we can use the layout function inside the plot function. Let's do an example. Let's define A equal to a normal distribution with mean equal to 1 and standard deviation equal to 3. And let's define a B is a gamma function with shape equal to 1 and rate equal to 3 as well. Now we can plot. Let's plot A first, and then we plot B with layout equal to 2, 1. We can add a label for our two different curves. Label equal to, for the first one is normal, and the second one will be gamma. So here is our plot with two subplots. In the final part of this video, I'm going to show the plots of the two different linear regressions my teammates fitted in the previous video. The first plot I'm going to show is a scatter plot between X, which is minutes played per game, and Y, which is points played per game. We can see that the scatter plot looks like it has a tail that goes up. That's why my teammate fitted a log transformation to the second linear regression model. Now I'm going to plot the regression line to the scatter plot. Here is our regression line. Now I'm going to show the scatter plot for the second regression model, which x1 is still the minutes played per game, and y1 is the log transformation of points scored per game. Now we have the scatter plot of the x versus y, which is minutes played per game and points scored per game. Now I'm going to add the regression line to the scatter plot. And here is our final result. That's all I'm going to cover in this video. Thanks for watching.